point in quantum chemistry is wave mechanical concept of the atom. So, we all know that the atom has two different parts. First one is atomic orbitals, while second one is atomic nucleus. Atomic orbitals involves electrons. So I should say that the electrons resides in the atomic orbitals, or I should say that the electrons rotates or moves in atomic orbitals. Another thing is that which is atomic nucleus. Now, atomic nucleus is consist of two different things. Number one, proton. Number two, neutrons. And these two combines together to form our atomic nucleus. So let's understand that what this wave mechanical concept can give us the idea or can give us the study of an atom. So, Bohr, the scientist named Bohr, gave the first quantitative successful model of the atom. But now it has been superseded completely by modern wave mechanical theory. So, the first structure or the first study of atom is given by Bohr. But afterwards, modern theories come into existence, and that modern theories take over this Bohr's theory. They are known as wave mechanical approach. So let's understand that what is a wave mechanical approach. Now, two different theories combines together to form this concept. Number one, wave, and number two, mechanical. So what the wave theory tells us? So according to the wave theory, radiations such as X-rays, UV rays or IR or microwaves consist or are basically made up of the waves traveling in the space. Now let's see the another approach. Another approach is mechanical approach, right? So now the wave mechanical nature, the wave nature of the light, however, failed completely to explain the photoelectric effect. What is the photoelectric effect here? So emission of the electron from the matter surface by the action of light. So how can we understand this photoelectrode or photoelectric effect? It has been observed that when the light is imparted on the metal surface, that particular kind of metal surface actually emits the electrons. So if we understood that an atom has a wave nature, then how can we explain such kind of electronic or such kind of particle nature of it? So to understand the particle or particulate nature of an atom, two different scientists have given the theory. The scientists named Planck and Einstein in 1905 proposed that energy radiations are emitted discontinuously as little photons. So what is the meaning of this? Actually, they have shown that the particular kind of light moves as a bundle of photon. So here comes the particulate nature of an atom. Now, when this both combines together, like light exhibits both a wave nature as well as a particular or particle nature. Under sustainable conditions, this theory, which applies to each and every kind of radiations or all radiations, is often referred to as the wave mechanical theory. Right? Now, the new quantum mechanics, which takes into account the particulate and wave, both the kind of nature into consideration, is termed as wave mechanics. So here comes wave mechanics or wave mechanical approach of an atom. So according to this theory, it gives us the idea that atom can be possible as a wave and can be possible as a particle. So this theory afterwards, first came Bohr's model, after that came wave theory, after that we have mechanical theory, but at last the latest or the modernist theory is wave mechanical theory or wave mechanics, or I should say wave mechanical concept of an atom. All these are the name of the theories, of the same theories. Okay? This is very important to study or to understand modern chemistry. So to study applied chemistry, it is required by us in order to study the wave mechanics, right? As it gives us the idea about where the actual electron is. Now, let's move further. Here, what we will have is, now as you can see it here, next point is Heisenberg's uncertainty principle. The scientist named Heisenberg has given this principle of uncertainty, and because of it, it is known as Heisenberg's uncertainty principle. Right? Now, one of the most important consequences of the dual nature of the matter is the uncertainty principle developed by a scientist named Werner Heisenberg in 1927. Right? Because a particular atom has both the nature, wave and particle. So uncertainty comes certainly, right? For an example, the position and the momentum of the moving particle are interdependent and thus conjugate properties also. So what is the meaning of this conjugate properties? So the properties which are depending upon each other are known as conjugate properties. So what we will have here is position and momentum of an atom, right? So they are interdependent. If you observe one, then another one will be there, right? So according to that, according to Heisenberg's uncertainty principle, it is impossible to know simultaneously both the conjugate properties accurately. Obviously, you get the data, right? But the data is not accurate. If you obtain the value of any one conjugate property, then it's an accurate one. But if you obtain the conjugate property, or if you measure both the conjugate properties simultaneously, then it will not be measured accurately. Uncertainty is there, right? Let's see it. Now, the uncertainty measurement or in measurement of position, that is delta x, and the uncertainty of determination of momentum, that is delta p, we can write it as m delta v, right, are related by Heisenberg's relationship. The uncertainty principle is only and only important in considering measurements of small particles. That means I should say that it is only and only applicable to the atomic systems, the systems which are smaller in size, and it can't be applicable to the larger objects here. Okay? Now, let's see that how we can write it. So, Heisenberg's uncertainty principle can be written as delta x into delta p is greater than or is equal to h by 2 pi. So, here as you can see, it gives us the relationship between these two conjugate properties. First one is delta x, that is change in position of an electron, and another one is delta p, that is change in momentum of an electron. So both can be related with the use of this uncertainty equation. Okay, so we can write this as delta x into m delta v, as we know that velocity of the particular or moving object, a particular moving object can be changed, but mass will not. So here we take mass as a constant and we will change delta v. We will change the velocity. So delta x into m delta v is greater than or is equal to h by 2 pi, where h is Planck's constant, right? As you can see it here, it gives us both the properties, whether we are talking about the wave nature and whether we are talking about the particulate nature. Next we will see that how it can be related with each other, right? So here this gives us the idea about any kind of atomic system. Next we will see in our next session. Thank you so much everyone.
No particular